Good morning, class. I hope y'all are doing well. I apologize. I had something come up, so I have to be out the afternoon. You can send me a message on Teams if you have any questions. So today you are again working asynchronously. So welcome back, guys. It is Wednesday, February 24th, 2021. Today we're continuing with double replacement reactions, and we're going to get in a good amount of practice for single replacement reactions as well. The assign yourself is to review notes. I'm going to upload the exemplar for this this afternoon, so it should hopefully help you review and get that work done as well. So for our do now, single replacement reaction, I know that this activity series looks a little bit different for the one that we're normally used to, but it works exactly the same. Basically, this one is telling you that the most reactive is up here, which is lithium, and that is correct. And the least reactive is down here, which is gold. So it is not active. Again, the one that we're used to seeing has our arrow facing upwards, pointing to most reactive. This arrow is pointing towards the least reactive. You're going to take about 3 minutes, class. Will cobalt replace barium? So cobalt is CO and barium is Ba. This one uses these symbols, so I think it makes it easier. Will hydrogen replace lithium? Lithium is Li. And will potassium replace lead? And lastly, looking at your example, will iron replace aluminum? Okay, guys, so you can pause me here. It should take you about 3 or so minutes, and right now we'll go over the exemplar. So welcome back, guys. Let's go over the answers really quickly. Will cobalt replace barium? So we're starting off with barium. Barium is right here. That is our current boon. And we want to see if cobalt will replace it. I know the wording can throw some people off. So cobalt is down here. Remember, we always want to upgrade, not downgrade. And this one has cobalt below or less active than barium. So will cobalt replace barium? No. Why? Because cobalt is less active. Cobalt is less active. So that reaction is not going to happen. And that is perfectly okay. Reactions don't happen all the time. So let's look at the second one. Will hydrogen replace lithium? So I'm currently with lithium. Lithium, guys, is our most active metal. There is nothing above lithium, so that should quickly tell you no. Nothing is replacing lithium. No. Hydrogen, sorry, that's supposed to be a comma. Hydrogen is less active. Everything is less active, actually. So nothing replaces lithium. Will potassium replace lead? So we're starting off with lead. Lead is down here. And will potassium replace it? Potassium is up here. Yes, this is an upgrade. So yes, potassium is more active. So again, this is just a quick review of how to use the activity series. This one looks a little bit different, but the concept is the same. You're always going to want an upgrade. So let's move on to the next one, class. Looking at your example, will iron replace aluminum? So aluminum is right here. Will iron replace it? Iron is below aluminum, so it is less active. This answer should have been no. Iron is less active. It is a downgrade, and we don't want to downgrade, guys. We want to make sure that it is an upgrade. So going into practice, a single replacement reaction. Again, you always start off with your coupled metal. So this is the metal that we're starting off with, which is aluminum. And the one that is going to replace it, guys, is the single one. So they call it like Mr. Steal Your Girl or something like that. So can iron replace aluminum? So let's just fill it out. What are the metals in this reaction? We're working with aluminum and we're working with iron. Non-metals, we can skip that question. What metal's getting replaced? So the one getting replaced is the one in the current relationship, so is aluminum. And what metal is doing the replacing? The one trying to replace it is iron. It's always the single one. That's the one trying to break them apart. So looking at this, we do not have to balance this reaction. Why? Because look at this. It is a downgrade. Iron is less active than aluminum. So this is just a simple no reaction. So iron is less active than aluminum. And that's it. That's all you have to do so you can get your answer for this one. That is the first type of product or type of answer that you can get for a single replacement reaction. And here's our second type. What are the metals in this reaction? We have single aluminum and we have hydrogen. Hydrogen is not a metal, but it has metal properties sometimes. So the metals in this reaction are aluminum and hydrogen. We can skip the non-metal question. What metal gets replaced? So remember, we're always replacing the one in a current relationship. So it's going to be hydrogen. Which metal is doing the replacing? Our single one. And does this reaction happen? So we always go with hydrogen. Hydrogen is down here. That is our current boo. And the one trying to replace it is aluminum. So this is an upgrade. Aluminum is more active. So does this reaction happen? Yes. Aluminum is more active. So because it is going to happen, it is up to us to balance this equation. So we're going to balance it very quickly. I'm going to just draw a table, my reactants and my products. My reactants, I have aluminum. I'm going to put sulfate. Sulfate stays together because it's a polyatomic ion, and hydrogen. Again, I listed the same: aluminum, sulfate, and hydrogen. So how many do I have of each? Here I have 1 aluminum, I have 2 hydrogen, and 1 sulfate. That's my reactant side. On my product side, after the arrow, I have 2 aluminum, I have 3 sulfate, and I have 2 hydrogen. So hydrogen is balanced. I'm not too worried about that. Next one that I will balance is my sulfate. I have 3 on my product side, but I need 3 on my reactant side. So I'm going to put that coefficient there. So this tells me I have 3 times 2. Now I have 6 hydrogen. I have 3 sulfate, and I have 1 aluminum. So again, I have to go back and now I have to fix that hydrogen because now I have 6 hydrogen on my reactant side. So I need 6 hydrogen on my product side. I'm going to put a coefficient of 3 because 3 times 2 will give me that 6 that I need. So I have 6 hydrogen, 3 sulfate, and 2 aluminum. I'm almost done. Sulfate is balanced, hydrogen is balanced. Now I need to have 2 aluminum on my reactant side. So here I just simply put a coefficient of 2. And now I have 2 aluminum. I still have 3 sulfate, and I have 3 times 2. That gives me 6 hydrogen. Now we are following the law of conservation of mass, which tells me that it has to be balanced. So if you want to completely write it out, it would be 2 aluminum plus 3. This is an acid, sulfuric acid, and it is going to produce aluminum sulfate and hydrogen. So again, it is up to you to completely write it out, but these are the 2 types of answers we can get. You are to work on 3 on your own. So answer the questions. You do not have to worry about the non-metals. A big clue, guys, is 2 of these, 2 out of your 3 are no reaction. So just make sure that you completely take advantage of using that activity series. You can pause me right here, practice those 3 questions, and right now you can press play so we can go over the answers. Make sure to practice, guys. So welcome back, guys. This is our first reaction. So what are the metals in this reaction? We're working with Na and Ca. This is calcium and this is sodium. What metal is getting replaced? So the one currently in a relationship gets replaced. That is calcium. Which one is trying to replace it? The one trying to replace it is our single one, which is sodium. And does this reaction happen? So over here, I'm currently with calcium. That's my boo. That's the one that we're bonded to. And the one that wants to replace it is sodium. Sodium is below it. Sodium is not an upgrade. So will this reaction happen? No. Na is less active. So this answer is simply no reaction. And we are done with question 1. So again, always use your activity series to help you answer these types of questions. Now let's look at our second example. What are the metals in this reaction? We are working with potassium and Au is gold. So potassium and gold. What metal is getting replaced? It is the one in the current relationship. So potassium's trying to be replaced by who? Our single metal is Au, which is gold. Guys, gold is the less reactive. Gold is not replacing any metal whatsoever. So will this reaction occur? No. You can double check your work. We can look at potassium. Potassium's up here, guys. So our current boo is potassium. The one trying to replace it is gold. Look at the big downgrade that occurs here. That is not a reaction that is going to happen. So no, Au is less active. It is the least active metal listed there. So it's definitely a no reaction. And again, we get those answers. It is perfectly okay to have a no reaction. And lastly, here we're working with magnesium and silver. So those are my two metals, magnesium and silver. We can skip this non-metal question. What metal is getting replaced? So the one that I'm currently with is silver. So I can put my heart over here with silver. And the one trying to replace it, trying to steal our girl, right, is magnesium. Magnesium is up here. So magnesium is a very big upgrade. Is this reaction going to happen? Absolutely, yes. Magnesium is more active. So magnesium is more active. Again, I'm just going to draw a quick table of reactants and products. Here I have magnesium, I have silver, and my polyatomic ion is nitrate. I'm going to keep the same order for my product side, magnesium, silver, and nitrate. Again, reactants, and then your arrow points towards your products. So we're going to list them very quickly. I have one magnesium, I have one silver and one nitrate. Magnesium on this side, I have one, I have two nitrate, and I have one silver. So magnesium and silver are good to go. I need to balance that nitrate. So I have two on my product side. I want two on my reactant side. I'm going to put the coefficient there. So this tells me now I have two silver, two nitrate, and one magnesium. I balanced out nitrate, but when I balanced out nitrate, I caused an imbalance for silver. So I need to have two silver on my product side. I'll just put a coefficient of 2. And we are balanced, guys. That's all it took. So if you look here, I have one magnesium, two silver, two nitrate, two nitrate. My reactants equal my products, which is what I want in a balanced equation, and you are done. So again, make sure you keep practicing. If you want to retry the problems again once you have your exemplar, it'll definitely help you out. So back to double replacement reactions. If you remember, double replacement reactions are between two ionic compounds and two cations are switched. So what happens is an ionic compound is a metal. Remember, metals are always listed first, and a non-metal. So I have a metal and a non-metal. And cations, if you remember cations, this gives it away. Cations is a positive charge, so this means you're working with metals. So basically that's it. You have a metal, a non-metal, plus a metal and another non-metal, and the metal switch. That's the big gist of double replacement reactions. So again, you determine your cations and your anions. Cations are positive, anions are negative. You switch them. So just make sure you're switching both metals, one this way, one this way. And then you balance. We're going to balance out our products. For today, I'm skipping that for now. I just want to concentrate on the aqueous, soluble and insoluble part of double replacement reactions. So we're going to skip this section. You can try it again. We did go over it yesterday. Very important, our vocabulary. We have to know what we're talking about. So disassociate means to split up. This is a perfect image of it. This is water, and water is splitting up our molecules. If something is soluble, that means it dissolves in water. Definitely a need to know to help you on that exit ticket. Soluble means you dissolve in water. Insoluble, you do not dissolve in water. This does not dissolve in water at all. And an exceptions means not included. Most of the time when you have an exception, guys, what happens is it does the opposite. You're going to see that right now. So again, please know that soluble dissolves in water and insoluble does not dissolve in water. Again, when you have something that is soluble, it is aqueous. And when you have something that is insoluble, it's a solid. It can be a solid, liquid, or gas. But most of the time we use solids. And again, this comes back up. Soluble will dissolve in water. Insoluble does not dissolve. So if something dissolves, it is. Try to answer it on your own. If something dissolves, this means it is soluble. And when something is soluble, it is aqueous. Insoluble, this does not dissolve. So how do we do this? We are going to look at our products. If you remember, our products is after our yield arrow. So this is our products. And we're going to see if we produce soluble, something that is aqueous, or insoluble, something that is solid. Remember, soluble means it is going to dissolve, and insoluble is not going to dissolve. So let's look at the solubility chart. This one looks a little bit different from yesterday. I wanted to try one that might be a little bit easier for you to understand. So nitrates are, a nitrate, guys, is NO3. So nitrates are, all nitrates are soluble. What nitrates are soluble? All of them. So if you see NO3, that is going to be soluble. And remember, soluble means it is aqueous. What hydroxides are insoluble? So hydroxides that are insoluble are a solid. A hydroxide means it is OH. So all hydroxides are insoluble except, that word is very important. When you use the word except, it means it is going to switch. So insoluble is solid. Anything after except means it is going to be aqueous. It will be soluble. So what hydroxides are insoluble? All hydroxides except those with sodium, potassium, barium, and calcium. So what hydroxides are insoluble? All except, our four exceptions are potassium, sodium, calcium, and barium. So what halogens are soluble? That one we can look here. All are soluble except when they're with silver, lead, and mercury. So this is all except silver, lead, and mercury. And lastly, what ammonium compounds are soluble? All sodium, potassium, and ammonium compounds are soluble. So all. Whenever you have, this is very important, we're going to see it a lot right now. Whenever you have sodium, potassium, and ammonia, these are soluble. They are aqueous. They will definitely dissolve. So hopefully this graph or this solubility chart is a bit better than yesterday's and easier for you to understand. So this is an I do. Here I have potassium hydroxide and magnesium chloride. So potassium, I can see here. Potassium, all sodium, potassium, and ammonium are soluble. So remember, soluble means aqueous. So I know that it's going to be aqueous. I can also double check it with hydroxide. Hydroxide are insoluble. They are solids except. So remember, when it says except, it means it is going to switch over. Sodium, potassium, barium, and calcium. I am with potassium, so that automatically tells me this is soluble. This is going to be aqueous, and it is going to be soluble. It is an exception of hydroxide, and it also lists it down there. Sodium, potassium, and ammonium are soluble. They're aqueous. Let's look at magnesium chloride. So looking at magnesium chloride, I see chlorine right here. All chlorine, bromine are soluble. So remember, soluble means it is aqueous, except silver, lead, and mercury. I'm not with silver, lead, or mercury. I'm with magnesium. So I'm going to stick to that answer of aqueous. This is soluble. Again, it is up here. Soluble is aqueous. Insoluble is a solid. Let's try this one together, guys. I want you to quickly look. Here we have potassium and sodium. Potassium and sodium are listed here. And I want you to use that to answer the following question. You can pause me here. You can also look at chlorine. You can see exception. The exceptions are there. And let me know. Okay, guys, so potassium and chlorine, these are soluble. So our product here will be aqueous. It is soluble. Our next one, sodium carbonate. Carbonate is also here. Carbonates are insoluble except, so that is aqueous. It's going to switch to the opposite, sodium, potassium, ammonium. And sodium, potassium, all of those guys, they are insoluble. Sorry, they are soluble. So this one's actually a soluble answer. Sorry, I did it incorrect, class. Yeah, because it is an exception, and the exception is sodium. This makes it soluble. Because remember, normally they are insoluble. Normally they are solids, but whenever we say there is an exception, that means it does not follow the rule. It breaks the rule. Sodium breaks the rule, so this means it is aqueous. And remember, we said at the beginning, anything with sodium, potassium, those are all soluble. They're aqueous. We're almost done, class. Here is a you do. You can pause me here. What you're looking at here is calcium and hydrogen. I'm sorry. And you also have sulfate and phosphate. The exceptions are right here. Calcium is one of them, and phosphates are there. So you can pause me here, try to answer it on your own, and then I'll set you up for your exit ticket. Welcome back, guys. Hopefully you're able to answer these correctly on your own. All sulfates are soluble. So remember, soluble means they are aqueous unless or except you have barium, lead, or calcium. Calcium is actually part of that exception. So except the opposite of soluble means it is insoluble. This is going to be insoluble, a solid, because it is an exception. It does not follow the rule. Next, we have phosphate. All carbonates and phosphates are insoluble. That means they are solids except sodium, potassium, and ammonia. This is not sodium, potassium, or ammonia, so it's going to follow that rule that it is insoluble. It is a solid. Okay, guys, and here is your exit ticket. If you go under assignments, it is actually under 224. I'll make sure to tag you in there. This is the image that I added on there. It asks you to look for potassium chloride and calcium hydroxide. So again, you have potassium. That is a big giveaway of what it is. And hydroxide. You can also double check with chlorine up there. There is a total of 6 questions. They're about 16 to 18 points each. Try your best on the exit ticket. It is for a grade. I'll make sure to upload exemplars right now so you can have that guide you in answering your problems. Again, guys, I'm so sorry I had to be out. I wasn't expecting this, but I hope you have a great afternoon, and I will see you tomorrow. Bye, guys.